of radical functions, listening. Remember how I said we just finished the transformations unit, and we're going to need to know how to do transformations in the next 3 units. Okay? Radicals and rationals, so 2 different types of functions in 1 unit. Okay, so we're going to use those properties of transformation. We kind of already did transformations back in that 20 of quadratics, which is a type of polynomial function. Remember, we talked about inverses. When we take the inverse of a quadratic, we get a horizontal parabola. If we just look at one arm, then that is the square root function, okay, a radical function. In terms of radical functions, we're really dealing with just square root. We're not looking at cube root or fourth root or whatever, right? So, just be aware of that. So, let's look at the inverse of a quadratic. You know what it looks like. So, here is your y equals x squared. Inverse, you interchange the x and y coordinates, or remember, okay, this is your base parabola, y equals x squared, so now it's going to be a base parabola horizontally.
What I do is I literally turn the paper and draw a parabola.
Okay, yeah, you can turn your paper. I can't turn mine, but yeah, absolutely.
It's an artistically challenging.
Okay. Or you look at your points, right? 0, 0, inverse is 0, 0. 1, 1, inverse is 1, 1. Negative 1, 1, the inverse is 1, negative 1. So it's down here. 2, 4 becomes 4, 2. Negative 2, 4 becomes 4, negative 2. Okay? These, remember, are called invariant points. Okay? So, the relation y equals x squared is a function because for every domain value, there is only one range value. Take a look at your inverse. Is it a function? No, right? For every domain, there's now 2 range values. For almost all of the x values, except obviously this one, there's just 1. Okay? No. So, what's a restriction on the original so that the inverse is a function? Remember, try to get the most that you can. And I'm going to tell you here, let's keep it to be positive. So here, if I take the positive arm here, when I take the inverse, it's going to be the upper or positive arm there. So I'm going to restrict it to x greater than or equal to 0. Okay? So when I do that, this here, right, becomes this here. So now, obviously the original is still a function, but now the inverse is a function. So that equation of the inverse, if we actually, so I graphed it in red. If you're using pencil, it's a little bit hard. Maybe you have a different color. And just trace over it. If we think about algebraically, we start with y equals x squared. The inverse, x equals y squared. And we solve for y. Will be plus or minus root x. That gets us both arms. Okay? If we are restricting our domain to just be the right-hand arm, then that's going to be the positive arm of this, which means the inverse So for the restricted domain, the inverse is y equals positive root x, which we don't have to show the plus. Okay. Oh, I actually drew that over top. So here, if I draw just that restricted domain, sorry, I just did it on the original. So there's the original with the restricted domain, and then inverse. Okay, if I graph on my calculator, like with inverses, remember they are reflections over the line y equals x. So you think about folding your paper along the diagonal and they'll overlap. Why does that not look like it's equally spaced from line y equals x? I've graphed it on my calculator.
Because you set your window here.
Yeah, because the window here is, first of all, it's rectangular. So if you get a standard screen from -10 to +10 both ways, then it's not equally, it's equally spaced, but not equal compared horizontally with vertical. Okay? If you did zoom square 5, then it'll be equal both ways. Okay? Now it's going to draw the whole parabola because I can't restrict it in there. But then you kind of look at it, oh yeah, now if I go along that diagonal, it'll look like it'll overlap. But just don't be fooled by your calculator. The calculator screen is not square, it's a rectangle. Right? So if you use your standard window, then -10 to +10 is stretched out a little bit more horizontally than vertically, because it's a rectangle this way.
Can you get the calculator to display functions with restrictions?
I think you can, but I never do. So I think you can go, I think you can actually go comma.
But is there an inequality sign?
There is.
I think it's a comma. There's a comma, but.
There is, where is it? It is, oh, test. Wow.
Close enough.
Oh, maybe graphics?
No, that'd be like times x is greater.
It's, I don't know. You'll have to look into it. It's something like that. You can restrict it with the inequality signs. Square brackets?
Yeah, those 21.
Those are on the calculator?
Yeah.
That's my second bracket, and you get like 21.
Oh, that probably would work.
Did you put, so you just went the squiggly graphics like this?
Yeah, yeah. Because,
I was gonna say, yeah.
Oh, it works!
Yeah! Wait. No.
Not mine. What did it do though? It went, what did it do?
Yeah, well, they're all.
I don't know what it did.
It looked like,
Maybe you can put a comma into it.
it looked like an exponential function.
Yeah, I don't know what it did, but there's something. It's not going to be part of the course, so I'm not worried about it. Okay. So there's your base graph. Root x. Gotta know it just like you did for y equals x squared. You shouldn't have to plot a table of values. There's one there if you need it, but you should know that you can kind of do the table of values in your head, right? Choose x values that are perfect squares. So, and then take the root of them. Positive root, because there's nothing in front, which means positive. So 0, 0, 1, 1. Root of 4 is 2. Root of 9 is 3. Root of 16 is 4. Try to make it curve as best you can. Okay, it's not a V, sideways V. Not a curve too.
Why does it always sound like there's something happening unless you're next door? Like,
Maybe there is.
like it's just screaming and stuff's getting thrown.
Doing some talking. Okay. So, square root of a, so think, read this full sentence before you fill it in. So y equals root x. Since the square root of something number does not exist in the real number system. Square root of what kind of number does not exist? Negative. The domain of this is going to be x has to be greater than or equal to 0. Okay. You can go to table values and do it. So domain of your base radical function is x has to be greater than or equal to 0. Just always remember that you can't take the root of a negative. That's going to help you get the domain of any radical function. So the shape of the graph is half of a horizontal parabola. We still call this a vertex. Okay, you know, with a parabola, the vertex is actually a turning point. In this case, it's not a turning point because it stops there or starts there, but we still call it the vertex. So this is at 0, 0. So your base graph also has, it has a range of y greater than or equal to 0. If you're taking, this is your base graph, is y equals root of x, which is the positive root of x. Okay, now we're going to do our transformations. So it says, all the transformations, including stretches, reflections, and translations, can be applied to radical functions. Use your transformation skills to complete the following. So here is a new function, okay? It says state the transformations in the correct order that were made to the original function to create this. So we want to look at, so this is our base graph. Anything in front of that, any factor, would be a stretch, maybe a reflection vertically. Any coefficient of x would be a stretch horizontally. Anything added to x would be a horizontal translation. Anything added outside would be a vertical. So this has a 1, so there's no horizontal stretch. Saying that, it's kind of similar to a parabola. There could be a vertical stretch that could give you the same result as a horizontal stretch. But And in this case, we're just showing it as vertical, right? Because if we had 4 there, that's where the 4 is 2, so it's the same. In any case, we're going to say exactly what it is. So I'm just going to use my abbreviations. So vertical stretch by a factor of 2 about the x-axis. Okay. Then a reflection. That's -2, so that's changing the sign of y. So that's in the x-axis. And then here, that's like having brackets there, right? So horizontal translation, left 1, and a vertical translation, up 4. Okay. So then it says use the transformations to sketch the graph. So just like we did in the transformations unit. We've graphed the original for you. So take nice points. So 0, 0. Stretch is not going to change it. Reflection, not going to change it. 1 left, 4 up. Notice, compare it to back when you did parabolas. The vertex of, so when we had a parabola, like that, our vertex was 2, 2. Kind of the same, except instead of squared there, it's square rooted. So our vertex is -1, 4. Okay? So you don't even have to do the transformations, you can actually go to that vertex. Next nice point here, y value is 1, stretched by a factor of 2 vertically is 2. Reflecting is -2. To the left 1, up 4. Okay. Makes sense that this makes it arm is going the opposite direction. So instead of normally going up, we've reflected in the x, so it's going down. Okay? Makes sense. And then the shape of it, it's stretched vertically, right? That's longer than this. This was 1, this was 2. Okay? Another nice point here. Y value is 2, stretched is 4, reflected is -4, left 1, up 4. I'm just going to erase the and another nice point here, 9, 3. 3 times 2 is 6. Reflect is -6. The left 1, up 4. And then we can do this last one, the space. So 4 times 2 is 8. Reflect is -8. Left 1, up 4, so -8 plus 4 is -4. So kind of like parabolas, when I graph a parabola, I do not go through all the transformations of every point, right? So if I know I have to graph y equals -2, x minus 1 squared plus 3, I go to my vertex right away, 1, 3. And I know, really, if I did all those transformations, I have to stretch it, reflect it, and then do those translations to here. So I need to, from here, draw the correct shaped graph, which has a stretch by 2 and opening down. So for 1 unit over, the base graph usually goes 1 up. Now I'm going to go 2 down. And same on the other way, right, to get that shape. So you could here, we said use transformations, but you could look at this and go, okay, my vertex is -1, 4. it's got to open the other way, right? The arm has to go the other direction because it's negative. And it's stretched by 2, which means 1 unit over has to be 2 down instead of 1. Okay? So, and then 4 units over is normally 2. Now it would have to be 4 down from there. So you could actually graph that without having to go all through the transformation. You'll have to see what your comfort level is for doing that. Okay? So we've graphed it. What's the domain and range? So domain, you can look at your graph. It's from -1 to infinity. Let's use some interval notation to practice that. And range is from +4 to -infinity. Okay? So you have to put, if we're using interval notation, you have to go from smallest to largest. So smallest is -infinity to 4. Okay?
I remember when I first saw that notation with the expansion of brackets, I thought it was a typo.
Yeah. Okay. So, again, you can graph it to find that out, or just think about, remember here, we know that the radicand has to be greater than or equal to 0. So that means x has to be greater than or equal to -1. So if you did set builder notation, you have that. Right? Same thing. For, if you didn't have the graph, you know that your vertex is -1, 4. So you know 4 is really important in your range. And then you want to look at which direction it's opening. If it's positive, then it's 4 to infinity. If it's negative, it's from -infinity to 4. Right? It's one or the other. And that's what that is. So this would be okay, so the point 25.5 lies on the original. We just don't have it on our graph. We don't have enough space. Determine its corresponding image point on the new graph. Okay, so 25.5, vertically stretching by 2 would be 10. Reflecting would be -10. And then the translation. So we're going left 1 and up 4. Okay. And then you can verify. So left side, right side. So -6. And right side. So that's going to be -2 times 5 plus 4, -10 plus 4 is -6. Left side equals right side. Okay, algebraically determine the x and y intercepts. Y-intercept is the easiest, right? That's when x is 0. Check on your graph. Was the y-intercept 2? Sure was. year we solved radical equations, so we're doing that again this year. Here is basically to find the algebraically find the x-intercepts, we have to solve that radical equation. Check on your graph. Did you get the same as the x-intercept on your graph? Okay, different one here. Again, we graphed the base graph for you. It says state the transformations in the correct order. And then you're going to be asked to sketch the new graph. Biggest thing here is to take a look. There's nothing outside in terms of the vertical stretch. Inside, there is a coefficient on x. So make sure you factor first. Now, if you don't factor, that's fine, but factor in your head, right? So that you know that it's a horizontal translation of 6, not 12 left. So this will be a horizontal stretch by a factor of 1/2 about the y-axis, then a reflection in the y-axis, because you're changing the sign of x, then a horizontal translation, right 6, vertical translation, down 5. Okay, so you start sketching now. Now, the likelihood of us asking you to sketch this on a test, probably pretty slim. Why do you think it is? You think it's too hard, too easy?
It's kind of challenging. There's a lot
What
of.
about your calculator?
Oh.
Oh, you can do it on your calculator. That's right? So, because we know what the function is, right? It's not like the transformation of some other random graph. We know 2x plus 12 minus 5. Oh, I put negative 5 on the That's a grade 10 error. Okay, so looks kind of different shape, but remember that's the scale markings. If you go trace, it'll give you the y-intercept. You don't know exactly, it looks about right, but if I go trace to what I think the vertex is, I get negative 5. Got that point right. Then I also got this point of 5.5. Negative 4. Yep, got that point. You can go through and check. You could also do your table features. Second graph is table. It will go through, give you values. You could set your table. So set your table to go in, so let's start at like negative 6 and go up by, I don't know, 0.5. Oh, I guess I didn't have the values. And then go to table. And then you can look at, okay, where I want to check at negative 2. There's negative 1, right? That's what I thought it is. Then I could keep going to 1, 4, that's right, 1.5 is negative 2. That's what I thought. So you can check it that way. So that's why you're probably not going to be asked to graph it yourself. You might have one, right, on the R test, but not your diploma. You would likely be given a graph and then asked to come up with an equation. Okay? And then you can always check, right? Always check. If you're asked to come up with a graph of the equation of a graph that's given to you, figure out best you can what you can do. Okay?
Is that
Graph there. Compare your points. That was the batteries, I
They're not. They're super light. Oh yeah, they're super.
Okay, that would be your domain and range in interval notation. So remember, you're always going left to right, or bottom to top in terms of the order there. And again, say you didn't even want to think about what it looks like, anything. You just know for sure, though, that negative 2x plus 12 has to be greater than or equal to 0. Right? You can't take the root of a negative. If I solve this, this is a good reminder, actually, and get x term by itself, and now divide by negative 2, what happens to the direction of the inequality? Changes. Do not forget. Okay, so this ends up being x less than or equal to positive 6. Whenever you multiply or divide an inequality by a negative, it changes the direction. Because really, from here, I could add 2x to get it over to the small n, add 12 to get it over to the big, then the treatment would be positive 2x at the small n. So I need this positive x at the small n.
Like, just think about it like -3 is larger than a -4. But if you divide both sides by -1, -3 is not larger than 4.
Right, exactly. Fine, so okay, be quiet, please. Okay, so now the point 36.6. Again, don't just substitute 36 in there. You have to take the transformations of that point. So 36.6. So what did we do? We did a horizontal stretch by a factor of 1/2 and reflection in the y-axis. You could do that all at once. That would be 18, change the sign, -18. Then the translations, 6 right would be -12, down 5 would be 1. We can check 1 for our y value, see that? -2 times -12 plus 12, and minus 5 outside. So 24 plus 12 is 36. And 36 is 6. Plus that equals right side. Okay, and then the x and y intercepts. Just like we did before. Exact value in simplest form. So this would be -2√3 minus 5. Oh, it's a little harder to check, right? If you're looking back at your graph here, looks like about -1.5. Let's check out when. Well, actually, you can go from your table, but I'm going to go to my graph. Because remember, if I go trace, it often goes right to the y-intercept. If I copy that y value out, which is alpha 1, there it is. Then from my algebra, I think it's -2√3 minus 5. Oh. I did something wrong, right?
Why'd you put the extra negative?
Why did I put the extra negative in there? That's right. I just noticed that. I put an extra negative in there for some
I was like, what did I do wrong?
reason. Okay, so now let's check it. That's why we check. So now I'm going to go. Okay, here's another fun fact with your calculator in case you didn't know. You see, newer versions, like most of you know this, but you can go up. If you can cursor up and select the previous line, that means that you can copy it and go back and edit it. It really depends on what version you have of your calculator. Okay.
Wait, there's a delete key? Oh, I've been rewriting equations for like, okay.
Wait, what?
Big box steps. Delete.
I hate everything right now.
I'm in the same boat as you, Jackson.
I used to get so, yeah, like, you know what, you screw up, like, you put in the wrong number for the exponent, or you get to cursor out of the exponent, you get, like, x to, like, to the 2 plus.
Yeah, yeah.
Or, like, you know, where it's, like, x divided by 2 minus, like, oh, crap. And then you
Okay,
get,
so that's
like,
your x intercept.
Thanks for enlightening me. I guess.
That's what annoys other students during the test. Yeah,
Oh, well, that guy.
during sequencing series. That's the most fun time.
Why?
When a student doesn't remember, where's my calculator?
Oh, so they just actually multiply all
So
the
a student
terms.
doesn't remember like the formula or something for the 50th term, so they put in the first term 12, and then they add plus 1. Then they lose track, but anyway, plus 5. And then it drives me nuts because I can hear it,
And you know exactly that it's.
and I know what we're doing.
Oh, that's hilarious. Oh, you know what? I saw this equation and it just shattered. After I finished the test, I
Okay, so let's focus. So I got negative 13 over 2, which is what, negative 6.5? When I graphed it, I didn't actually go that far, but I have it on my calculator. And so let's trace. You can go find the zero of that function. That requires you to go left, right, boundary, blah, blah, blah. If I think it's negative 6.5, be in trace mode, go negative 6.5, and make sure you get y equals 0. Right? That's the fastest way to do a check. Intersect is the second fastest way. Enter y2 equals 0 and do intersect. Third fastest is to find the 0 of that function. The fastest or close. Okay, here's, this will be a common type of question that you might get. So the original base graph is vertically stretched, in this case by factor of 4, horizontally stretched, reflected, translated. Be very careful here about what form to write it in. So in this case, it's okay to have an A value and a B value, no horizontal and vertical. Just keep them in there. If it didn't have the B, or didn't have the A, you're going to have to use your properties of square roots to show it that way. So here, you can show each step, but we know it's vertically stretched by factor of 4, horizontally stretched by factor of 1/3, reflected about the x-axis, that means this would be negative 4. Translated 6 up and right 5, so bracket x minus 5, and then plus 6 outside of it. Okay, so you don't have to go step by step. We did a whole unit where I did a lot of step by step. Now hopefully you're getting comfortable with that. So if this didn't have an A there, then, well, actually, in this case, because it's negative, it would have to have an A. Say it was positive, but it didn't have an A, then you would square this to put it inside there. Okay? Okay? Mapping notation could be any function. So this, correct order, this would be horizontal stretch. I'm just going to do them abbreviated so that we can finish this up. With me, horizontal stretch by 5, reflection, changing the sign of y, so in the x-axis, horizontal translation, left 6. Vertical translation up 7. Okay? SRT, sketches, reflections, translation, in that order. So write the equation. So A, in this case, there isn't an A, which, if I had say I said in a numeric response that you had to give A, B, C, D, no, not C, D, A, C. What would you put for A in your numeric response? 1, okay, not 0, right? If there's nothing in front, that means a 1.
Wait, but it's reflected.
Oh, yeah.
And you wouldn't have
Okay, I
negatives
haven't
in
seen it.
there.
All right. No, get it. It's negative 1, but yeah.
No, no, we get QSEC. We got QSEC.
Yeah, it wouldn't be in a numeric response because it's negative, but anyway. Hopefully you kind of get what I'm talking about. So horizontal stretch by 5 would be 1/5. Reflect in the x-axis would be negative, so your A value would be -1. Okay, folks?
So I
Quiet,
guess
please.
in that case, for an numeric response, what you might do is you might do like negative.
Yeah, something like that, yeah. Translation horizontally, so I do need brackets. X plus 6. Vertical 7 up, so plus 7 outside. Okay. So for the transformed function, what's the domain? Okay. Well, think about it. Everything underneath the square root has to be greater than or equal to 0. Does the 1/5 really come into play for that? No. So really, you only care about that bracket if it's in factored form, right? So x has to be greater than or equal to -6. So let's use interval because it's a little bit easier when you don't have the graph. Usually, for interval notation, we use a colon. For set builder, we use an equal. It didn't ask me for which type, so either one. So that would be set builder. Sorry. Okay, range. So think about this. Your y value is 7, but this has been reflected in the x-axis. So instead of the arm going upwards, it's now going downwards. Okay? So that means it's going to go to -infinity from 7. So it's going to be 1 less than or equal to 7. Or -infinity to 7. Okay. So whatever this constant term is going to be that number, right? The negative tells you if it's below that or above that. Looking back at this one, so back to what is A, B, C, D, just so we get practice when we get to the numeric response. So A is -1, B is 1/5, H is -6. This is a plus here, this is a minus. So in order to put a number in there to get a plus, it has to be negative. So this would be -6. and the k plus plus, so that would be 7. Okay? So if that was a multiple choice where we listed them all, that's what you would look for.
You're right. A lot of mathematicians pay good attention to detail.
Especially in the calculation stuff.
Yeah, because one little thing can change everything.
Okay, and then we are coming up with okay, so as I mentioned, this would be more likely for something. Given a graph, we have to come up with the equation. So the graph of y equals root x and another radical function is shown. Determine the equation of the other and express in that form and verify with your calculator. That's what you would do on any test, right? So what I would look at, right, your base graph, there's your vertex. Normally 1 unit is 1 up, 4 units is 2 up. Okay? Here's your vertex. 1 unit, now we're going the other direction, but 1 unit to the left now is 3 up. 1 unit is normally 1 up. So, what kind of vertical stretch could we give? 3. So, vertical stretch by 3. Okay. Now, what direction? I had to go left to do that. So would I reflect in the x-axis or the y-axis? In the y. Right? So it's going, instead of this way, it needs to go this way. And then you stretch it and move it. Right? So that's going to be a reflection in the y-axis. And then the vertex there is 2, 4. So horizontal translation, right 2, vertical translation, up 4. Okay. I didn't have to write it there, but I did. So now let's test it.
No, just think about it. Your point should be 1. What is it? Well, look at it. It's like, you know, when you're looking at a parabola, if you see that the point that's 1 over is 2 up instead of 1 up, here, the point that is 1 over is 1 up. I mean, you can also express that as a horizontal stretch of 1/3. Oh, wait, no, because it has to go or 1. Wait, what? 1.
This and in there is each line.
Oh, yeah. Oh, yeah, because, right, that makes sense.
Okay, so let's check out.
Oh, yeah, because
We could check by hand, but let's check on our calculator. Because that's what it says to. So I think it's 3 square root negative bracket x minus 2 x minus 2 close bracket outside of the radical. Make sure you cursor out of your radical in your calculator. I'll just do it. Oh, I didn't do a standard thing today. Go back to standard. I always do standard and then change it if I need to. Okay, so size looks different. Certainly looks correct in the shape of it. If I trace going to my y-intercept 8.2 something, well, it looks like I'm close, right? So I want to check certain points. I'm going to check 2, 4. So trace 2, 4. That's good. 1, 7. So trace 1 for x. 7. Good. Y-intercept looks good. I think I got it.
So we did it differently, and then we checked on the document because that's the same.
Sure. Like a different way, you got a different step?
Yeah, we got it kind of clean.
What'd you get?
It's 3 over 2, and then root -4, and then bracket x minus 2.
Oh, say it again.
Okay,
Did you say root negative?
Okay, say it again.
Okay, y equals 3 over 2, and then square root -4, and then bracket x minus 2, and then plus 1.
Okay. That's very more complicated.
Yeah, and then that multiplies by
But see how it works, right? You put this back in there, that's 9 fourths times -4 is -9, right? If you factor out the 9, or just the 1/2 even. 1/2 goes in there, that would be 1/4, so it simplifies it.
yeah, no, you
It
can
is
also
correct, but it's not in simplified form. So, yeah, it works. How would you get that?
Basically, I went from 1 to 16, and calculated that it was 16, and then
1 to 16?
no, on the x-axis. And then for the which was 1, I went from the vertex to x equals -2. And I found out the horizontal stretch from that, and then I can simplify that.
Oh,
I mean,
that's harder. You're making it harder.
I mean, you couldn't mark that wrong.
Okay, so, take a look at this one. So it says determine the equation of a radical function in this form. So now, you couldn't have, you gotta be careful, right? You can't have a horizontal stretch in this one. So if I said here, say this didn't have a reflection, and I said that wasn't there, right? No B in there, then you would have to do it my way.
Actually, yeah.
If there was no reflection. So just be aware of what it looks like there. Okay, so determine the equation. So, domain and range. This is your x value at your vertex. So your vertex is 5, 8. So you can get your vertex from your domain and range. Given this is a good hint for you, okay, because we can't have a horizontal stretch. Otherwise it'd be more than one answer, right? So now we can fill in y equals a, read x minus 5, and then plus 8 outside. Basically, it's very similar to your parabola questions back from Math 20. Okay? You would find your equation of a parabola given the domain and range, or given the vertex. Basically, we're given the vertex, we're given another point, so now you put 6 in for y, 21 in for x, and solve for a. So it's very, very similar to working with a parabola and finding a value.
Just, yeah.
Okay, anytime you have a question like that, please make sure you rewrite it with all of the values correctly entered. I'm kind of running out of space, but put that A value back in. Okay? Because it didn't say specifically what is A, it says what is the equation in that form. So you have to show the form. Okay, and then 7, find the inverse. So just be careful, right? This is a radical, it's one arm. The inverse, when you square both sides, once you interchange x and y, you're going to get a parabola. So then you have to restrict that parabola to one arm. Okay, so you gotta make sure you restrict it to the correct one. So here, inverse. Do that. Square both sides. And in this case, it doesn't say how to express it, so I'm actually going to keep it in vertex form. Keep it as x minus 5 squared. Oh, what am I doing? Oh, yeah, yeah. Okay, so there's my original. It looks something like this. Okay. I calculate or I do my algebra to get my inverse. So I interchange x and y, solve for y. Now I get a parabola. It would have two arms here. That's not the inverse of a radical. Right? A radical is one arm. This would have two arms. So I've got to restrict this so that I only get the one arm. In this case, the right-hand one. So I want x to be greater than or equal to, where x is greater than or equal to 5. Then it's the inverse. You can't suddenly have more of a graph than you had before, right? You take the inverse. And that's it.